Question number 10 from trigonometric ratios and angles. Find the exact value of the following, leaving the denominator in rational form if necessary. So it is cotangent of 30 degrees times sine of 420 degrees minus cosecant of minus 135 degrees and secant of 300 degrees. Well, you can pause the video, solve the question, and then look into my suggestions. Now, to do these kinds of problems, what we need is our special triangles and the cast rule. So let's go through both of them. So first I make a coordinate system here which will help us to understand where which trigonometric ratio is positive or negative, and second we'll have our special triangles, right? So I'll draw two special triangles here. One is for 45 degrees and the other one which will have 30 degrees, 60 degrees and 90 degrees, correct? So these are the special triangles. Now let me write down the numbers which are more important in this. For 45 degrees, we know these two sides are equal. So if this is 1 and this is 1, we have square root 2 here. For 60 degrees, equilateral triangle, let's assume all the sides are 2 and 2. So when you drop a perpendicular, it divides into two equal parts. So each is 1, right? Now if hypotenuse is 2 and a base is 1, then 2 square, which is 4, minus 1 square, which is 1, gives me 3. And square root of 3 is the side opposite to 60 degrees. Now in this, 60, 90, so that has to be 30 degrees, correct? That gives us some total of 180 degrees in this particular triangle. Now these two triangles will help us to find all different values in exact form. Now what is cast rule? Cast rule says that CAST starting from quadrant 4, right? Quadrant 1, 2 and 3, right? This is basics which we'll need to solve this question. So I just drawn it for you. Now let's look into the question. We say cotangent of 30 degrees, right? So now here we have angles which are more than 90 degrees, and what we will do is we'll write them as equivalent angles. So cotangent of 30 degrees, that means 1 over tan, right? Or we can even write cotangent, but it's good to write 1 over tan at present. I'll tell you why. So we'll write 1 over tan 30 degrees in this case, sine of 420 degrees. That means sine of 420 degrees means, well, look at like this. So 360, so one full circle, right? So one full circle is 360, and how much more? So we do 420 minus 360, correct? So we get 60 degrees. So we get 60 degrees more, so that means that this is the angle, right? So this is the angle for sine 420. So that is 60 degrees, correct? And that's in quadrant 1. So we can write this as sine of 60 degrees. Correct, since 420 degrees is actually equals to 360 plus 60, right? So now we can write this as cosecant of minus 135. Now when we say minus 135, that means we are moving clockwise, right? So it is 90 plus 45, correct? So that is 90 plus 45 is 135, correct? This is 135. That means here we are left with 45 degrees, right? So this basically becomes 45 degrees, right? So we have cosecant of 45 degrees. Now one more important thing is that if I have to write this, now use cast rule. Now cosecant is reciprocal of sine, right? Sine is negative here. So this will be negative in this case, correct? So we should write this as negative of cosecant 45 degrees. Now secant of 300 degrees. Secant of 300 degrees will really mean that we are moving clockwise like this, and then we go up to here, right? That is secant of 300. That means 360 minus 60. So acute angle here is 60 degrees, correct? So acute angle here is 60 degrees. We could write this as 360 minus 60, right? That is how we can write this. So I can write, instead of secant 300, I can write this as secant of 60 degrees in terms of acute angle. Now in this quadrant, cosine is positive, and therefore secant will also be positive. So this is what we get here. Now what we can do is, we can plug in the values from our special triangle. When we say tan of 30 degrees, now what is tan? Well, some of you also use SOHCAHTOA. So let me write down SOHCAHTOA here so that we will use SOHCAHTOA and then figure it out, right? So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, right? So tan is opposite over adjacent. So if you see from 30 degrees, right, then opposite is 1 and adjacent is square root 3, right? So we get here 1 over square root 3. So I can write square root 3 on the top, correct? So that is how we can write this. Now sine of 60 degrees. Sine of 60 degrees, sine is opposite over hypotenuse, right? Opposite over hypotenuse. That means square root 3 over 2. Minus and minus is plus, so I'll make plus here. 45 degrees cosecant. That means this is reciprocal of sine, right? So 45 degrees, sine will be 1 over square root 2 and reciprocal will be square root 2 over 1, right? So I'll write this as square root 2 over 1, no need to write that. Secant is reciprocal of cosine, right? Cosine 60, which is 1 over 2. So reciprocal will be 2 over 1. So I'll write this as 2, correct? So we get it like this. So we can write the given trigonometric expression as shown here. Now if you multiply 3 square root with 3 square root, you actually get 3 over 2, and here you get plus 2 square root 2, correct? So that is the answer. If you want, you can also take common denominator of 2, right? And then you can write this answer as 3 plus 4 square root 2, correct? So that is how you can complete this question. But a couple of important things here is, you should remember that all these trigonometric identities should be written in acute angle form, right? That is one thing. Now when you write them in acute angle, you have to consider in which quadrant you are so that you can put the right sign. Perfect. Once you have put right signs in the acute angles, you can use the special triangles to get the values. And then you can do your math to get the answer. I hope that's absolutely clear. Thank you.